Hello, beautiful people. So here is my first homework help for the year. So let's go ahead and jump right in. And I'm sorry I don't have a paper copy, so I'm going to go ahead and do this using my computer and a sheet of paper. So it sounds like people are having trouble setting up number one, so I'm going to go ahead and set it up for you all. So it says problem set. Shelley compared the number of oak trees to the number of maple trees as part of a study about hardwood trees in woodlot. She counted 9 maple trees to every 5 oak trees. Later in the year, there was a bug problem and many trees died. New trees were planted to make sure there was the same number of trees as before the bug problem. The new ratio of the number of maple trees to the number of oak trees is 3 to 11. After planting new trees, there were 132 oak trees. How many maple trees were in the woodlot before the bug problem, then after the bug problem? So I'm going to go ahead and zoom in on this question. How many maple trees were in the woodlot before the bug problem, then after the bug problem? So I'm going to go ahead and use this sheet of paper to organize my thoughts. So I know, because the question mentioned it as being important, we got to think about 2 specific things. We got to think about pre-bug problem or before the bug problem. And since the question mentioned it, we're also going to talk about after the bug problem. So I'm going to, I'm still not sure what information I need. So I'm going to reread the text. And when I reread the text, I'm going to see if there's any key information I can pull out, and then I'll model it down here. So looking back at the text, Shelley compared the number of oak trees to the number of maple trees as part of a study about hardwood trees in woodlot. She counted 9 maple trees to every 5 oak trees. Later in the year, there was a bug problem. So she counted 9 maple trees to every 5 oak trees, and this was previous to the bug problem. So I'm going to make a ratio chart here. And there's 2 types of trees. There's maple trees, and there's oak trees. And I have someone calling me. And it says that there were 9 maple trees to every 5 oak trees. So I'm going to put that here. There are 9 to every 5. Pre-bug problem, there are 9 maple trees to every 5 oak trees, all right? So let's see if we can find some information about after the bug problem. So going back to the text, it says, later in the year, there was a bug problem and many trees died. New trees were planted to make sure there was the same number of trees. So there's going to be the same number of trees as before the bug problem, but there's a new ratio, okay? So we know they're going to be equal or equivalent. The new ratio of the number of maple trees to the number of oak trees is 3 to 11. So again, it's maple trees to oak trees. So I'm just going to make another ratio chart. Maple trees to oak trees. And then the new ratio is 3 to 11. So there's 3 maple trees to 11 oak trees, all right? So we know that these are our 2 ratios that we're given. So I wrote them both on a ratio chart. I'll show them on a tape diagram too. But that's the information. I just organized it on my paper for now. So let's go back and make sure we're actually reading the question. We got all the information we need. So last 2 sentences. After planting new trees, there were 132 oak trees. So it says after planting new trees, that's after the bug problem, there were 132 oak trees. So I'm going to come down to my chart and I'm going to write 132 under oak trees because that's important information. So let's go back, and you know what, just from here, I hope that you know enough about ratio charts to know what to do in this situation. So I'm going to go ahead and hope that you see that since you know a ratio relationship is proportional, that since maple trees are always going to be 3 to 11 oak trees, that if there's 132, whatever happened to this 11 to make it turn into 32, we got to do that same thing to that 3. So in order for us to know what happened to this 11, we have to actually think about, how do we use ratio tables? So usually when we're thinking about ratio tables, we take this top number and we multiply it times something to get the bottom number. So we have to think about 11 times what equals 32. 11 times, sorry, it's hard for me to hold this iPad. 11 times what equals 132? Some of you might be able to do that math in your head. Some of you are like, I still don't know. Let's go ahead and use division. So right here, I'm going to say 132 divided by 11. Well, 11 fits inside 130, it fits inside of 1 0 times. It fits inside of 13 one time. 1 times 11 is 11. 13 minus 11 is 2. You bring the other 2 down. So you're repeating the process. How many times does 11 fit into 22? It fits in twice. 2 times 11 is 22. 22 minus 22 is 0. So our answer is 12. So we know 11 times 12 equals 132. So I hope you recognize from it being a ratio chart, whatever we do to one side of the ratio chart, we do the other side of the ratio chart. So if we're trying to figure out how many maple trees, if there are 3 maple trees for every 11 oak trees, when we have 132 oak trees, if we multiply this 3 by 12, we'll figure out how many maple trees there are. So 3 times 12 is 36. So then there's going to be 36 maple trees. So let's go back to the question and see if we answered it yet. And again, I keep telling you guys this and I want to emphasize it. You need to reread the problem over and over again until you fully understand it. So I'm going to read it again. Shelley compared the number of oak trees to the number of maple trees as part of a study about hardwood trees in a woodlot. She counted 9 maple trees to every 5 oak trees. Later in the year, there was a bug problem and many trees died. New trees were planted to make sure there was the same number, the same number of trees. So that means that pre-trees, post-trees, we should get the same number. So that means that these ratios are proportional to each other. So let's keep reading. Same number of trees as before the bug problem. The new ratio of the number of maple trees to the number of oak trees is 3 to 11. After planting new trees, there were 132 oak trees. How many more maple trees were in the woodlot before the bug problem than after the bug problem? Do we know how many maple trees there were before the bug problem? As of now, we don't. But since we know there were the same amount of trees, we just have to figure out what ratio of trees there were. And the way we do that is actually we multiply it, and we call it a C in class, but our C is 12. We're multiplying both of these by this 12. So we're going to use that same 12 to multiply over here. We're going to go ahead and multiply the 5 times the 12, and we're going to multiply the 9 times the 12. So 5 times 12 is 60. 18, carry 1, 9, 108. 9 times 12 is 108. I did that in my head. Hopefully that's right. I would do a long division if you don't know. And let's see if we answer the question. So I did it using a ratio chart. You can do the same thing. The way it would show up on a tape diagram is you would just draw 5 and 9 and multiply both of them by 12. I'm sure you all know how to do that. So look at this problem one more time. The question says, after planting new trees, there were 132 oak trees. How many more maple trees were in the woodlot before the bug problem than after the bug problem? So we actually need to look at the maple trees before the bug problem. There were 108. And after the bug problem, there were 36. So what we have to do is we have to find the difference, because it says how many more maple trees were in the woodlot before the bug problem than after the bug problem. So that means that since we're trying to figure out how many more, pre-bug problem there were more maple trees, there were 108. And we got to find the difference. How many more than after there were 36? So how do you find the difference between 108 and 36? This is where I'm going to leave you. I'm going to let you figure this part out. I believe you can do this. Find the difference in maple trees between 108 and 36 maple trees. And then I want you to go ahead and write a sentence to actually answer that question, explaining your work. So if you still need help, comment below. And I'm actually going to encourage teammates to answer each other's comments because I think you can solve this. I believe in you. Have a wonderful evening. Remember that the two ratios that show up in the problem are proportional to one another. Have a great evening. I'll talk to you soon. Bye.